In this experiment, what I'm going to do is to change the symbol rate of the transmitter program that is running on the Arduino here, so that the baseband frequency can be altered. And I'm going to measure on air what is the power that is emitted by this antenna. So I'm going to use a device which fundamentally has an antenna here and measurement electronics on this. And the result is I will be able to look in the frequency domain about the power that is coming out from this antenna. This is a screenshot from an oscilloscope showing two traces. The yellow is the signal that the Arduino program is sending to the transmitter module. So that is the periodic change of symbols. And the blue trace is the one which is measured at the antenna. So this is the RF signal that is output at the antenna. So you see when the symbol is held high, the antenna outputs high frequency oscillation. So this is 433 megahertz oscillation. The reason why you're not able to see the individual lines of the sine curve is because of the time scale. But what you see is when the symbol is held high, you have oscillation, and then when the symbol is low, there is no oscillation, and so on. I'll later be explaining to you that this sudden change of the modulation of the carrier wave from being silent to starting to modulate here. So this transition plays an important role in determining the bandwidth. Let's now look at the spectrum. So what we are having here is the spectrum when the symbol duration is 50 milliseconds. So if you remember, 50 milliseconds corresponds to a bit rate of 20 bits per second. So around the central frequency, you see that the signal occupies a certain band of frequency, and this is qualitatively the bandwidth here. Now what I'm going to do is to dramatically reduce the symbol rate or increase the bit rate from 20 bits per second to 1000 bits per second. So let's see how this now affects the spectrum. So now the transmitter is at 100 bits per second, and what you see immediately are the side lobes on the adjoining frequencies. So you have energy being emitted here, but in addition to that, there are several lobes of decreasing power around it. And this is the effect of the modulation kind. So the abrupt change in the waveform from flat to a sinusoidal form. This is the one which causes the emission of frequencies in these side harmonics. And you will be learning in your lectures and later exercises that you can play around with this by bringing the next adjoining channel frequencies to fit in between these gaps. So that is what the orthogonal frequency division multiplexing does. So as we go on decreasing the symbol duration or increasing the bit rate, the lobes on the side would get worse. So as you see now, we are at half a millisecond symbol duration, and you see the power on the side lobes is increasing. So what we have seen is the effect of bit rate on bandwidth, and furthermore we see that apart from the energy emitted in the central frequency of the carrier wave, there are also adjoining frequencies that carry some energy in it. So hopefully this brings a little bit of clarity on RF waves and the effect of digital communication on bandwidth.